Welcome to Instrumental Analysis. My name's Vicki Colvin, and I'll be your professor for this Coursera class. What we're going to do in this introductory lecture is I'm going to tell you a little bit about instrumental analysis, some of the expectations the class may place on you if you're fully completing it, and a little bit about the grading policy. So instrumental analysis is a subset of analytical chemistry, and it really describes the use of modern instrumentation to figure out what's in stuff or some sort of sample you might be interested in. Analytical chemistry broadly is really concerned with analysis. In instrumental analysis, it's the application of modern tools such as mass spectroscopy, chromatography, infrared spectroscopy to figure out what's really in something, both all of the different components as well as how much of those components might be present. So why do we do instrumental analysis? Well, there's a whole bunch of reasons, and in fact, it's one of the most fascinating areas of chemistry, in part because of the very diverse set of issues it touches. So one of our case studies in this class is going to be on lead in children's toys. You may have heard a lot of the controversy surrounding toys that might be brought in from other countries that might contain paints or colorants that have toxic elements such as lead present. We're going to be looking at how we analyze for that and how accurate and precise those measurements can be, and really the context of a measurement of lead in things like baby toys. It can also be important just to understand things you care about. We're going to talk about chocolate in our chromatography section. And chocolate's an amazing substance. It's extremely complex. It has purported medical benefits, and we certainly all know that it tastes great. So how do we analyze what makes chocolate such a wonderful substance for many of us? What makes it silky in the mouth? What gives it that chocolate flavor? And it's unusual as a food because there's not a single molecule that we can identify that's responsible for the perception of the taste of chocolate. And finally, in our life cast study, we'll talk about the use of instruments for the law. So as far as topics, this is an 8-week Coursera class, which is really a half a semester of instrumental analysis. So what I'm going to do is cover topics that really are related to the fundamental instrumentation that you need to do metals analysis, as well as chromatography and a little bit of spectroscopy at the end. And that's really half of a semester. If there's interest, we'll go ahead and complete the class in another probably 6-week segment, which would focus on the topics shown here on the right. More spectroscopy, a little bit more on basic molecular analysis, so mass spectrometry for molecular analysis, and also some NMR. So how do I decide what's in and what's out of the class? Well, first off, I am very aware of what most of the modern textbooks in analytical chemistry and instrumentation teach. So that sort of gives us a set of what are the instruments that most of us find useful as we go on in our careers as chemists. I also based a lot of the topics we're covering off the American Chemical Society standardized exams in both analytical chemistry and instrumental analysis. You won't be ready to take either one of those after this 8-week Coursera class, but you'll be well on your way to completing the work you need for instrumental analysis ACS exam, which is an accredited exam offered by the American Chemical Society here in the United States. So based on that assessment, this class is about 80% instrumental analysis, and it's got about 20% what's called quantitative analytical chemistry. We will be talking about error and understanding error in this very first week, and those topics are usually reserved in the sort of broader analytical chemistry curriculum, but they're so critical for understanding our case studies that I really needed to introduce them right away at the beginning in this class on instrumental analysis. So who are you? It's an interesting question, and I hope to find out from the surveys. Once I do, I'll share that information. But for now, this class really is designed for chemistry majors who are in their junior or senior or sometimes their sophomore year. So it's a core part of the chemistry curriculum. And that's really how this course came into being. I've taught analytical chemistry at Rice University for over 5 years. And what I wanted to do was to take components of that class and put them in an online format so as to share them more broadly. So I would anticipate chemistry majors who are looking for some extra activities, or in fact may take this class, and then if I offer a second one, the second part of it would have a full introduction to instrumental analysis. If for some reason they couldn't take it at their college, let's say they're interning or they're going overseas. You might also be an adult learner. Instrumental analysis, unlike some of the other analytical chemistry topics, is something you can do if you have good freshman chemistry experience. It doesn't require a deep familiarity and rapid facilitation with problem solving. more the basic concepts of chemistry. And so I expect maybe some advanced adult learners would be interested in sort of reviving their chemistry knowledge and learning about some really cool modern instrumentation. What you shouldn't be is somebody who is a full-time analytical chemist or somebody who's intending to do that. This is really a survey class. It's going to be rigorous because it is designed to be in some ways very similar to a college course, but it's really not designed for an expert in the area. So what about the background that you need to take the class? That's going to be a big issue. I've put up a pre-course quiz that you should take, and what that quiz is going to do is give you information about what I consider to be knowledge you should have in your head. You shouldn't have to Google it. Although I suppose if you do Google it and can handle it that way, that might be all right. So that's going to be the most important barrier, I think, for people taking the class. This is an advanced chemistry class designed for people who've already had freshman chemistry. Some of the things you've got to know is you've got to know what sulfate is. It's SO4, it's got a charge of 2-. You have to know how to find its molecular weight. Things like polarity of molecules such as methanol and benzene need to be familiar to you. And you may be able to do some of that using Google, but it could get very arduous. So if those are questions that seem really foreign to you, this class may not be for you. You should have access to some sort of spreadsheet and a calculator that can do standard deviations and averages and also linear calibrations. Calibration curves are really foundational in instrumental analysis, and you're going to have to be able to run a few of those on your own. Finally, I anticipate that the workload here will be 10 hours a week, plus or minus a few hours depending on the week. And I'll try to give you a sense at the start of the week if I think it's going to be a hard week or an easy week with respect to the number of lectures and the kinds of assignments that I'm giving, which brings me to assignments. So this is what the calendar is going to look like. We're going to start with the sort of quantitative analysis this week related to error bars. And then we're going to quickly move into atomic spectroscopy. Then we're going to transition to chromatography, and finally we're going to conclude with IR spectroscopy and electrochemical sensors. Now I chose those topics not just to choose random instruments, but because we're going to be exploring them through case studies. So the first case study we're going to do is lead in toys. And that's a really interesting case study. It brings up issues of sample preparation, as well as the limits of detection of instruments and how accurate and precise our measurements can be. Then we're going to transition to chromatography, where the case study will be chocolate. And then finally at the end, breathalyzers. Now each of these case studies will be due every couple of weeks, and they're going to be more short answer sort of discussion format, and they will be peer graded. The other kind of work you'll do every week are problem sets and quizzes. And the quizzes are going to depend on how much lecture material I gave you. Basically, they're reinforcing and making sure that you watch the lectures and can basically do what I did in the lecture. Problem sets are going to be a little bit more difficult. They're going to ask you to take one little baby step away from what was presented in a lecture. But it's not so important to me that you know it on the first pass. I'm going to give you a couple of chances to do the problem sets with the questions varying, and hopefully the goal is you'll eventually reach the bar in which I say, yeah, you understood the material for that week. So this taken together is going to allow you to get a certificate in this 8-week instrumental analysis class. If you complete 70% of the assignments and basically participate most weeks, so say you did 6 weeks and then stopped, I don't know if I'd give you a certificate then. But if you're basically participating, but there's some subset of stuff you just can't do, maybe because of your background or time limitations, that's okay. You'll still get a certificate. So I hope you stick with it. If on the other hand, you're a chemistry major, you have a very focused need for taking this class, I encourage you to go for a certificate with distinction, which I'll award to anybody who completes 85% of the assignments. Notice that when I say complete, I'll let you take the assignments multiple times in order to eventually succeed at them. And there'll be a lot of variations added. Most of the time, though, you'll be limited to between 3 and 5 tries on the assignments that I offer on Coursera. There will be a final exam at the end, which will sort of sum up and synthesize all the knowledge you've had throughout the 8 weeks. So I hope I've answered some of your questions about what the class is going to be like, in which you're going to come away with a deep knowledge of instrumental analysis. Thanks so much, and look forward to seeing you soon.